There's the 2020 question 1b. One is not there. A 60 gram mass. So 0.1 would be 100 grams. I always like just doing that to make sure I have the decimal right. So that'd be 0.06 for 60 grams. Projected vertically upwards with an initial speed of 15. U is equal to 15. We have its mass. And half a second later, so let's call this time t. And then we have something else happening. We have a 40 gram mass, 0.04, projected vertically upwards from the same point, initial speed 22.65, and we imagine that it's half a second later, so it's in the air for half a second less, so t will be equal to t minus 0.5. So what are we asked to find? The height at which they collide. So height is displacement, s is equal to ut plus a half at squared. It's projected vertically upwards, so we have gravity pulling it back down, minus 9.8 for my a. So s, we'll call this 60 gram, we'll call it a and b. SA, we'll call this guy p. Displacement for a is 15 t, so it's going to be half a, it's going to be minus 4.9 by t squared. That's all we can do so far for him. The displacement for b is going to be equal to u 22.65 times t, which is t minus 0.5, and it's also going to be minus 4.9 by t squared, which is t minus 0.5 squared. So we just have a little bit of work simplifying this. 22.65t minus a half, 22.65, so that's 11.650 will be 325 minus 4.9 by t squared minus 0.5t twice, which would be minus t, and then minus 0.5 by minus 0.5 is plus 0.25. Squeeze it in there, 0.25. So we've got 22.65t minus 11.325 minus 4.9 t squared plus 4.9t, and a quarter of 4.9 will be minus 1.225. So we're going to have to let these equal each other. So rather than writing them out again, we've lined them up. We can say these are equal to each other. The displacements, this is when they're going to collide. We can cancel our 4.9 t squared, and it looks like I have, how many t's have I got out? This one, and this one, minus this one. So if I type that into a calculator, I'm going to get 12.55, and that's going to be positive, so bringing the two negatives to the left, that's also going to be 12.55. And we're saying nice and evenly, t is equal to 1. They're going to collide after 1 second in the air. So the displacement will be equal to 15 times t, 15 times 1, minus 4.9 by t squared, which would be 15 minus 4.9. They're going to collide at 10.1 meters into the air. Then we're told the masses coalesce on colliding, so they join together, find the greatest height which the combined mass will reach. So this is 2 going into 1, so we've got this one and this one, all of a sudden they become this one, and continues on with 1 speed. So this looks like conservation of momentum, m1u1 plus m2u2 is equal to m1 plus m2, they're going to combine, times the new speed. So we have most of these, I think we have 0.4, what's the mass, is 0.06 and 0.04, 0.06 by, well, we need their speeds, don't we? So we need our new speeds for both of them. So what have we got here? We have u was 15, so v is equal to u plus at. So for a, we have the new velocity will be 15. Minus 9.8, and t was 1, so 15 minus 9.8 is 5.2 for the velocity here. And for b is equal to u plus at. Velocity for b is going to be equal to 22.65 minus 9.8 times, now it's going to be t minus a half, so 1 minus half is just 0.5. So 22.65 minus 4.9 is going to be 23. Not 23. It's going to be 17.75. Just take away 5 and add on 0.1. So there are my new velocities. So 0.04 by the 17.75. That will be equal to the two of them added together, 0.06. Plus 0.04 times the new speed. So we tidy all this up. We can type all this into a calculator in one go. I'm going to get the new speed 2b. We'll maybe do it in one step. 0.1v, left hand side to Edison 1.022. So multiplying that both sides by 10, we're going to get 10.22 for the new speed. And we want the greatest height reached. So they collide at this point, they have a new speed. So that will be my u. At the greatest height, the velocity will be equal to 0. We have a is equal to minus 9.8. And we're looking for the greatest height, s, v squared, u, v, u, a, s. So v squared is equal to u squared, 10.22 squared. Sorry, 10.22 squared. And I should probably write my formula. V squared is equal to u squared plus 2as. So 2a is minus 19.6 s. And we had v to be 0. So we have 0. So s is equal to 10.22 squared. We'll be dividing that by 19.6. So in one step on your calculator, we're going to get the greatest height to be 5.329 meters. And correct too. Just says find the greatest height, so we leave it at 5.329 meters. And that concludes this question.